Okay, I think we can start. I wanted just to introduce Professor Jussara Almeida of Universidade Federal de Minas Gerais, Brezil. You will pronounce better than me. Thank you for coming. And she is here in the frame of a small project that we have with the equipe between Laboratoire Samovar, Telecom Paris, and the equipe tribe of Iria, which is represented here. And so I think that we are very close. Links and equipe tribe is very close. So I hope that there will be more occasions to do something together, to exchange ideas, to have seminars. And so you're the first one. So thank you for being the first one.
Well, thank you. Thanks for the opportunity to talk to you about some of my work. So the talk is about information spread online. This is something that I've been doing for a while. But before I start talking about that, let me introduce myself. So I'm from Brazil, and I'm from Minas Gerais, which is the state in the southeast, and the capital city is Belo Horizonte. So we are not on the beach. We are not in Rio, not in São Paulo, but we are in Dubai. But lots of mountains around, short and small mountains, but nice scenery. This is our university on the left, the main campus. And this is my department. This is actually an old picture. It's almost 50 years old now, which for Brazilian standards for computer sciences, a nice amount of years on the go. And there we are around 60 people around, more or less, because there are many people who are retiring now, but lots of new people coming in. And we are doing, we have like this, as I said, 60 people doing research in many areas. And my area of research, and I always like to show this picture, is something that I did actually a few months after I defended my PhD many, many years ago. And it keeps like representing me. I just switched the scenario, but it's still the same thing. All my studies were in computer science, and actually I liked to tweak operating systems. I remember like crashing, burn Linux operating systems to see if I could make it work better. And this is like the early years of the PhD. And by the end of my PhD, there was this life change switch in my mind that I started looking at users, how users behave when they interact with the system, because I realized that I was always interested in performance. That is my goal. But I realized that we cannot understand performance if we do not understand how users interact with the system and generate workload. And since then, I'm increasingly looking at user behavior, but always from this perspective of how this behavior may impact the system, whatever the system is, and how the system design may drive, influence, impact user behavior. So my foundational knowledge is here, but I'm increasingly interested in user behaviors. And the research that I do at UFMG is in the locus, that's my lab there, the social computing lab. And currently I have the research that I'm doing, two main fronts. So one is the one that I'm going to talk about today, which is information dissemination, where I'm interested in understanding what drives content popularity, what makes a particular piece of content become very popular. And there's another front, which is actually the front that I work with people at Gerias and tribe, which is human mobility. But even though I work with them, I decided to talk about something new because they will learn a new facet of me, which is in information dissemination. Okay.
And the project we have with the Keep Tribe is on human mobility, how to understand human mobility. So you said,
yeah, so that's the common link.
Impact.
Yeah, that's exactly. There we are interested in predictability, how predictable the behavior is, how vulnerable it may be, and how to predict behavior in general. But today I'm going to talk about information dissemination. And here I'm interested in modeling user behavior from both individual perspective and collective behavior. Individual, one thing that we're doing, for instance, is, and that's the part of my brain that I usually don't exercise when I'm very focused on computer science, because I'm interested in modeling curiosity, how the curiosity of a person may drive her behavior towards sharing the content, towards reproducing content, forwarding the content, how this may impact information dissemination. So we have a student working on modeling curiosity. And there is another front, which is collective behavior. And that's my focus here today. And by collective behavior, I mean the kinds of activities engaged in by sizable but loosely organized groups of people. That's a general definition. And what I want to try to analyze is phenomena in general, driven by collective behavior. Okay, so I'll start with a discussion that is very broad, very generic, and then I will exemplify with some particular phenomena that we are interested in. Okay, so what do I mean by collective behavior? For instance, if in social media, which is my goal, probably I want to understand how users interact and how these interactions may drive and may trigger some phenomena, for instance, dissemination of particular piece of content. That's specifically the goal. And interactions here could be anything. Could be on Twitter, when Twitter existed, retweeting. That's a form of interaction. Sharing the same content. Two people share the same content. One person posts a comment on another person's post. Two people comment on the same post and they interact via those comments. Anything. And if you are modeling user interactions, most probably you will rely on some network model. Like, for instance, you build a network where you connect users that interact. They, for instance, retweeted the same tweet, they shared the same content. Usually, we, all of us who work with this kind of research, we build this network and we analyze this network, properties of this network, static properties, dynamic properties. And then I have two observations. The first one, I'm pretty sure that you all will agree, is that usually when you build such network from social media, the networks are usually very, very dense. Many, many, many edges. Easily, like a week or a month worth of data builds like hundreds of thousands of edges in the network. So very, very, very dense. The other argument that I have, and it's the main point of my talk, is that most of us build this network, deal with the challenge of processing all these edges, and try to learn whatever you're trying to study with the network. But the point that I want to make is that not all edges are equally important to whatever you're trying to understand. But even more, many of those edges may not be relevant at all. And I call this noise. Noise because they occur in such an abundance that they actually may mask and may obfuscate whatever you're trying to understand. So now when you have so many edges that are completely unrelated to what you're trying to study, and you try to analyze the properties of these networks, you have models of dissemination, whatever it is that you're doing, these unrelated edges will be on your way and may mask the whole thing. And the point that I want to make is that if you're studying such a network, such a noisy network, and that's my notion of noise here, you need to get rid of this. You need to identify and get rid of those irrelevant or less relevant edges and focus only on the truly relevant or salient edges for whatever it is that you're trying to study. These edges, the name they give to it is the backbone. So if you think of like telecommunication networks, you have a very clear notion of backbone, usually associated with topology, structural topology. You need to have the network connected. But here, backbone is a broader term that means actually is related to network specification. And the core of that is that your network, there are two perspectives actually. First is that your network is redundant, which is very easy to understand. If you're building like you want to build a backbone of the network with the minimum connectivity, you keep the shortest path and you remove the rest. You don't need, that's redundant. But for me, it's beyond that. It's not only redundance, it's irrelevance. And if you do not get rid of it, you'll be misled into a wrong interpretation. So it's not only Redundancy is also noise in the sense that it's irrelevant. So I need to identify those edges, and I need to remove them and focus on the really relevant edges. There are several methods in the literature. Like the simplest one is to keep the shortest path. And actually, that's a very nice method of network backbone extraction method, because there are many formal proofs of properties that you have with this method. But for me, it's not adequate, because for the kind of phenomena that I'm interested in, I don't need to keep all the nodes. Actually, I'm interested in a subset of the nodes. I'm going to give you an example shortly. Okay. And when you take the shortest path, you want to keep the network connected. We want to be able to reach all the nodes. So there are, as I said, there are different methods. Some like take a global perspective, some take a local perspective, some are structural based on shortest path, some are probabilistic. Now let me stop and give you a concrete example, what I mean by noise, backbone, etc. Let's suppose, so I'm talking about information dissemination. So I want to study, which is what I'm going to talk about today, coordination to promote content. I want to try to understand, to review groups of people who are orchestrating a campaign to promote a particular piece of content, to share that content. So first, usually, I do not have ground truth. I do not know that. Orchestration, coordination takes place in real life and is manifested in the data by the digital trace. So all I see is that Jussara shared something. Najib also shared the same thing. Okay. Are we coordinating or not? I don't know. So I need to infer that from the topology of the network. For instance, let's suppose that I build a network where I connect people that share the same content. It's a weighted network. So I connect to Jussara and Najib, and I put a weight on this edge saying, how many times this happened? Now I have to look at that and decide, is this a strong evidence of coordination or not? Maybe Jussara is not coordinating at all with anybody. Okay, so she's not part of the backbone for the sake of studying coordination. But maybe she is coordinating with someone, and I'd like to catch that. So as I said, there is no ground truth. So everything that I can do is provide evidence that maybe this is actually happening. And so I will end up actually having a evidence that it's like I will lean towards a probabilistic approach. There is a high chance that Jussara is actually coordinating, because her behavior is just out of pattern. And that's out of pattern is actually what the method decides. So one very simple strategy. Let's take the heaviest edges. Just look at who shared with whom, takes the heaviest edges. That's actually it's called threshold based. Take the top 10 edges with highest weights, or take all the edges that have the weight above this many. What's the problem with that? And actually, that's the first one that we tried for coordination, which is my focus here. The problem is that you end up missing many people that are not as active as the most active users, but collectively they contribute to the distribution. And it has to do with the property of the environment, of the social media. Some people are much more active than others. There's a Zipf law. There is a distribution that is highly biased. Some content are much more popular than others. So chances are that Najib and I will share the same content just because this content is very popular. And we're not coordinating. We stumble upon it and we decide to share completely independently. And if you collect these sharings over time, this edge between me and Najib, because we are very active, we will increase in weight. So it's not a matter of taking the weight and take the heaviest ones. Okay. So that's exactly the focus here. So note here that my backbone doesn't have some of the nodes, and I will only keep those that are with a high probability. And there will be a probabilistic test behind. I have high confidence that it's related to the phenomena in the case of coordination. So as I said, coming back, there are many methods. Some are global, like the threshold, take the heavy states. Some look at the edge or at the user, look at the Jussara. How is her behavior? Now look at Jussara and Najib. This behavior, this number of times that she shared the same thing as Najib, is okay for her? Could this occur by chance? Or maybe it's so high that it could not work by chance, and it's just result of coordination. And there are many different strategies that explore this kind of local approach, different properties. Some are structural, like shortest path. Some are probabilistic, as this one that I just mentioned. And when we started working with that, there were so many different methods, and the definition of the methods, the assumptions behind them were not clearly described. I mean, we have many different, many different papers on the topic, and each one has a different way of looking at it, and you have to have like this global idea. We missed this global strategy of understanding all the methods, of characterizing them. So we start by doing that. We took like 10 methods, and we characterized them according to their assumptions, their requirements, and we proposed a strategy that, given a target phenomenon like coordination, how do you select potential methods to apply to extract a good backbone for you? And how do you tell that the backbone is good, in the sense that it's actually reflecting whatever you're trying to study? So we have this strategy, and we applied that to two different contexts. One was online discussions, how to infer online discussions on Instagram. And the other, which is the one that I'm going to talk, is coordination, which is exactly the example that I just mentioned. How do I find groups of users for which I have high confidence that they should be coordinating to promote content? Okay. And we did that. We started with one case study based on WhatsApp on the Brazilian elections of 2018. So almost 6 years back. This was a major WhatsApp played a major role in this election. I mean, we didn't know when we started doing, but it ended up to be like a major player in terms of the final. Some people claim even the final results of the election. Then we moved on to study the US elections 2020. That's the one that we had the invasion of the Capitol on Twitter. And then the latest work was on the 2022 Brazilian elections. Here we studied two phenomena. One was early electoral ads in Brazil using Twitter. And the most recent one, this paper we presented next week on ICWCM, is extremist content in Telegram. There we try to analyze the use of Telegram behind the riots that caused the whole thing in Brazil. If you know that they broke down all the main buildings of the government, they tried to put the top, literally. So when we started that, 2018, we really wanted to understand WhatsApp. WhatsApp was not known in terms of platform. There were like one or two works on that. We started very naively in the sense, let's see what people are sharing this content. What's the characteristic of this platform as an information sharing platform? And we analyzed public accessible, politically oriented WhatsApp groups. We started focusing on images because it was easier. And as I said, 2018, but later on we moved to study text and audio content. And we did a lot of processing of text, of image and of audio, but process of the content. And in the process, we found out how we characterize how WhatsApp was being exploited for misinformation spread. So we characterize the type of content, the kind of lifetime of this content, how misinformation deviates from not misinformation, in the sense that they remain being reshared many, many times. And we also try to understand how information could be shared so many times, so large number of times in a platform where you do not have an explicit network, unlike Twitter, Facebook. There's no link. Here we have a group, here 256 people at the time, at most. And that's it. That was supposed, like a friend of mine used to say, that's like a table in the bar. You have with your friends, you're talking. And somehow things spread very fast. So we try to understand. And we start playing with different, we call it implicit networks, potential channels through which the information could jump from one group to the other. Let's say I'm in one group, I'm in another group as well. So if I receive an information here, I may decide to share there. So I'm a link between these two groups. So if you think this way, you can build different networks. And what we were surprised about is that when we analyzed the properties, the topological properties of these networks, they were very similar to Twitter, Facebook, with properties, qualitatively speaking, properties that had already been used to justify content virality. So very similar. Diameter, density, that favors content spread. And when I presented this paper, the first one, and I showed the image of the network, this one of the networks that we analyzed, one person said, but where are the guys who shared misinformation in this network? Have you looked at where in the network the users who share misinformation are? We hadn't, because we're just looking at the content. So then we start looking from that perspective. And we start by building what we call the media-centric network. Here are users, and I connect the users who share the same content, image, audio, text. Here is not misinformation, it's content in general, okay? It's a weighted network. And what I wanted to see here is if I find communities of users who spread the same content. And I'm already like thinking of trying to identify the potential for coordination here. And if you look at this network, and it's just like a sample of it, it's quite noisy. It's quite dense and quite noisy. So the community structure here, there is a metric for that, is modularity, is very short, very weak in the sense that it's very dispersed. So we need to uncover the salient edges. And by salient or relevant edges here, I want those edges that represent persistent and repetitive behavior. Me and Najib, repeatedly, we shared the same message over and over and over again. And we keep only those edges. And we try to uncover the communities from that map, okay? As I said, we had a strategy to try to apply different methods and define which one is best. So just to illustrate, this is the original network, the one on the left, A, and I have the results of 5 different backbone extraction methods here. And they are completely different. Like this one, the FASS, it's a structure-based, no community structure at all, horrible, right? And actually, if we look at the community structure, we have a way of trying to, based on regression, to see whether the edges are really related to coordination. If you look at all the metrics, you find that this one here was the best, which is disparity filter. Letter D was the one that I mentioned that just keeps the heaviest edges. It's not bad. It's actually good. It's simple. But what you miss if you use letter D, you miss lots of smaller communities that are not as active as the larger community, but collectively, they represent a large portion of it. It's the long tail effect. And we get that with this method, disparity filter. Why do we get? Because disparity filter takes into account the fact that users are heterogeneous. It makes a decision based on each individual. So I look at Jussara and says, this edge between Jussara and Najib is too out of the pattern of Jussara. Maybe not with Andrea. Andrea and Najib, Andrea is published much more than myself. So what is out of pattern for him is not what is out of pattern for me, or the other way around, actually. Maybe my edge, the weight of my edge for him is normal, but for me is not. So the idea of disparity filter is to make decisions on edge silence on a local basis at each node. And the idea is you look at the node, Jussara, and there's a reference model. The assumption is if Jussara is not coordinating or whatever you're trying to do, analyze, if she's not coordinating, the number of times that she shares the same content as her neighbors, the weight of the edges, should be roughly uniform, roughly. if she has an edge that deviates greatly from this reference model, that's an edge that you can keep, that you should keep. And this is a probabilistic test because you can be as conservative as you want. What's a great deviation? We try to be very conservative because we aim at precision, not recall, meaning that wherever we say there is coordination, there is a high chance there is coordination, even though we might be missing them. So we were very, very conservative here. It's like a p-value of 0.01, something like that in our statistical test. Okay, so once I did that, that's a sample of my original network. I got the backbone. I run Louvain, which is a community detection algorithm, and I got these communities. The first thing that I noticed was that if you look at, so the pink one, these are a group of users who are tightly connected. All of them are sharing the same content over and over and over again. If you look at these users, they are spread over different groups, many, many groups. Sometimes we have communities with one member in each group of the data set. So that's how you get a scale of spread. You have this massive amount of people, like soldiers, sharing the same content in every group they have. And then you get like hundreds of thousands of copies of a message. Fine. So communities cross group boundaries, which favors information spread, which basically means that this group notion is doesn't make any sense in terms of containing the information. And then came the question that the guy asked me when I present the first paper. Where in the network are the users who more often share this information? We started by looking at the centrality of those users. It's a basic metric, where in the network they are. And here, the red one are the top 10%, I think, users who share more misinformation. The dash blue is the top 10% of users who share more content in general, not only misinformation, just to equalize in terms of activity. And others. And as you see here, in different centrality metrics, the top misinformation users, they have higher centrality. They are better positioned in the network, which gives them efficiency of spread. But what about the backbone, Jussara? So if the backbone was meant to capture coordination, whatever I remove when I extract the backbone, I call that the periphery, which is not the backbone. Makes sense. So it's the periphery. These are those users for which I do not have enough evidence that they are coordinating. So I would just assume that they are acting independently. They may share misinformation, they may share the same content, but I do not have evidence of coordination strong enough for whatever I decide. What do I find when I compare the backbone with the periphery? First, the backbone is a small fraction of the network, both in terms of nodes and in terms of edges. We are really, really very conservative in keeping the edges. So we keep only 4% of the edges and 16% of the nodes. Yet, most, if not all, the top users sharing misinformation, those who share more, they are here. So they are actually coordinated. Yet, they represent 28 to 41, less than half, 41 at most, of everyone who is involved in sharing misinformation. This is like put numbers into something that we all know, that misinformation gets spread, but possibly initially based on some quote unquote bad guys who are coordinating to make it spread, but it's thanks to this massive amount of quote unquote naive people who share it without checking that the thing gets spread. And it becomes more evident when you look at the percentage of messages. Only up to 53% of the messages with misinformation. So around half, if not more, of the messages, if you look at all the messages of misinformation that circulated in the system, in the platform, viewed in our data set, they are mostly shared by these naive guys. Even though the backbone is responsible for introducing new content most of the time. So it's like this, the backbone introduces the content and a massive amount of people shares it.
Introduce the concept of misinformation in the last 4 slides, I think. does the coordinated action generate misinformation, or is that an independent assessment based on content?
I cannot tell whether the content is originally generated by them.
Whether you define
Misinformation
being spread by the organized groups of users that detect
within the view of WhatsApp that I have, they introduce. So it's all dependent on that. I don't know if you ask what am I, which I didn't say, I should have said. What am I, how do I say that it's, how can I tell that it's misinformation? I should have said that. So yeah, we relied on fact checking. So the way we did first is we submitted some of the message to a fact check agency and they labeled it. This obviously didn't scale. So the way we did to scale is we submitted the content to Google. It's easier to think in images, but later we did for text and for audios as well. We submitted the image to Google and we got the replies and we looked at whether in the result of the Google had any a link to a fact check agency in Brazil because the content is Portuguese. So we know the major fact checking agencies in Brazil. We had like 6 or 7. So we checked like, I forgot the name, but anyway, there are many. So we checked. Let's suppose that one of them were there.
What are the fact-checking agency? Are the agency working on, or are
Fact-checking. They are journalists responsible for doing fact-checking.
Are they governmental or independent?
No, independent.
Okay.
They are independent. Okay. Otherwise,
Okay. Otherwise,
it'll be a nightmare. Everything will change. No, they are completely independent, and that's important. And it's important also to say that we did not say that it's misinformation, because fact-checking is something that has to be done by those who know how to do it. It's a journalist, independent journalist. Let me just think. So there is something like Boatuja, which is one of them, I forgot. But let's say that there is a link to that agency, to the website. So we went to the website and we searched for the image and we saw the label that they gave. If they said fake, we marked as fake. If they said true, we marked as true. But let's suppose that we didn't have any response, right? So we don't know. So what we have here is misinformation for sure, checked, misinformation, and unchecked. So in unchecked, not checked, I don't know what else. Maybe there is misinformation, but we are not accounting for that.
But you consider it as misinformation here?
No, I consider it as not checked.
Okay.
So everything here is targeting precision, not recall. So we may be missing many things here because we can. Did I answer your question?
Yes. So it's an independent thing. So the other question, how to determine precision or recall with respect to a lack of ground truth?
No, I don't. No, sorry. I'm using precision recall here very loosely defined. No, especially because we have here, I don't remember, but we have a number of groups. It's like we don't even, I remember that I had a meeting with WhatsApp at this time. They couldn't even tell me the number of groups, public groups in Brazil. They don't keep, at least they said at the time. So we don't know what kind of, what portion of the universe we're in. There's no way of it.
Is there a way to do the fact checking like automatically? It could be like with the data set that you collected, you could do a classifier.
I don't trust that.
Oh.
That's true. That's too dangerous. Here you have to have the label. You have to be. That's something that has to be reliable.
It's because of the dynamism of the information?
No, it's because it's subtle. When we characterize the content, obviously there are some distinct patterns, but it changes a lot.
Okay.
From one week, something that it's not as easy, and it's very easy to change. Like I always think that looking at content, which we did, but I always think that looking at the content is like it's a race that you're going to lose, because you're trying to understand the patterns and they are changing it. You know, and then you learn, and then they already changed everything, and then you learn to learn everything else. So I think fact checking has to be a true label that you trust, done by those who know how to do independent. Okay. Yeah. So this here is to make an argument that we do need web literacy, media literacy, because it doesn't make sense to try to search for this guy, if the massive amount of people who are sharing content without checking, they continue doing that. So fact checking is something that people need to know that it's important. I know that in some places they already teach that in school. And what I want to say is that sometimes we search for technology as the answer. You go up to a certain point because you need people to react to that properly.
How the data was collected?
Yeah, so this was a crawler that was, we had a version, and then there was this partner of ours from media who built another crawler, but basically you find links to publicly accessible groups, which are links that are shared. You join it, you advertise yourself. If you stay there, you are able to access the messages.
Like
So
spies. Like
yeah, but we advertise ourselves in the sense that we are here. We are gonna, we mentioned that we are gathering data.
Ah.
But it's, in a way, but it was official.
Kicked out from a group because of advertising.
WhatsApp, no, but we've done something similar for Telegram, just did like this month. And there we did, there we got. And this is just to show how dynamic this backbone is, which also is a kind of disappointing because you think, oh, great, you find the backbone, you find the bad guys, you detect the bad guys. No, because the bad guys change, at least from the perspective of the system, because we have everything is anonymized. So week 1, Najib has ID 1, week 2, Najib has ID 5, and I cannot track him. And the structure of the backbone, the structure of the communities change a lot. So it's really hard to capture that. But anyway, life goes on. And then we moved to other scenarios related to fake news. Again, coordination. The next scenario was the online extremists during the US election. This was the election that lost, and they invaded the Capitol, those allegedly Trump supporters. And here we use Twitter, former Twitter. This was done when Twitter was, we could crawl it, but actually we did not crawl it. These guys, the Voter Fraud Project, they were responsible for this data collection and they shared with us. It's actually publicly accessible now. And what they did something very interesting. So during like the late months of 2020, the election, they collected tweets using keywords related to fraud during the 2020 election. So you build like a vocabulary of words and you collect tweets. So October to December 2020. January 2021, there was the invasion, just soon after, right? Days after the invasion of the Capitol, this was such a huge thing that if you could think of something that would like make the platforms do something, this was one thing, right? Twitter reacted to it because there was lots of discussions about Twitter being used to mobilize the people who invaded the Capitol, using the sense that they exchange information, right, in this sense. That Twitter went there and it carried out a massive moderation effort, suspending over 70,000 accounts associated with extremist content, sharing content, hate speech associated with fraud of the election, but something related to the invasion. And then what the guys of the Voter Fraud Project did, soon after that, they went back to the data set and they checked which accounts were still active. So because of the timing, most probably, if an account had been suspended or deleted, especially suspended, it had been suspended because of that. So that's what we used. We used this label as some sort of evidence that that user had been suspended by that moderation effort. And as such, he was involved. He was considered involved with extremist content. So what we did, again, we built a network connecting people who share the same content, in this case here, retweeting the same content. And we extract the backbone because it's a very noisy network. And in this case, DF, disparate filter, didn't work as we wished. This is the modularity, which is a measure of the quality of the communities. It's just as bad as the original, very sparse. And the reason for that which didn't happen with WhatsApp. WhatsApp was really nice. The reason here is that Twitter used to give you a sample, 1% of the data. When you crawled, you didn't crawl the whole Twitter on those words, you crawled 1%. And the reference model that the EF implements on partial data, on sample data, is not a good thing. It doesn't work well. Think you are assuming a certain distribution and you're inferring this distribution from a sample. So that's a problem. We didn't know that, we learned this, and then we changed the F to have an extra filter where we do not only focus on persistent and repetitive connections, but we also want to keep edges connecting people who have similar, we have many neighbors with similar behavior. So we are like crazily narrowing our focus on very tightly connected. So we are going to get rid of many nodes, of many edges, but these are very tightly connected. Again, near targeting precision. And then what we found? What we found is that, so here I have on the x-axis community size, and each dot here is a community that we extracted from the backbone from different weeks of analysis. On the y-axis is the percentage of users in the community, this community, around, I don't know, 2,000 users. It had around 65% of the members had their account deleted or suspended. So the very first thing is that, well, we have very large communities tightly connected. So it's like a farm of people, thousands of people sharing the same content. But Twitter managed to suspend a large fraction of some of this community, up to 60%. So from the perspective of the moderation actor, this was successful. But limits success, because you have many communities which remained almost completely active, just sharing the same content. And content like this. So clearly inciting people against the result of the election. So this is to attest the limits of moderation, which is something that people also say, we need engagement from the platform to moderate. Well, it's up to a certain point. If you could think of something that was really huge in terms of moderation, was this. YouTube tried something, especially in Brazil, 2022, but it was not near close to that. And still, many remain behind. We don't know exactly what guide Twitter to decide this one is suspended or not. But if you think of that its relation with sharing this kind of content, many remained active behind. Okay. Then we moved to the third event, which is the 2022 Brazilian elections. And here I had two fronts, and I'm going to talk very quickly about them. One was a collaboration that we had with the public ministry. So as I said, social media played a major role in the 2018 elections. So the public ministry decided to look at, well, social media is an important platform during elections. Let's look at that. What's going on this app? And one thing that we have in Brazil is early electoral propaganda. Electoral propaganda during the election year is regulated and highly enforced in the sense that no one can share propaganda promoting any candidate, future candidates, before a certain date, August something or July of the year. And this is enforced in mass media, TV and radio. And the public ministry wanted to know what's going on in social media? What do we have there? Are they using it for electoral propaganda? And we did the same thing again. Well, not so easy because we had the whole thing of identifying electoral propaganda, which was not easy. Because I could say something like, this guy, without saying the name, this guy who built, I don't know what, is gonna make your life better next. And that's considered propaganda. Electoral propaganda, even though he is not a candidate yet. There is a notion that it's very subtle, that only them know how to identify. It's very, very hard. So we had to work a lot and try to detect those. But once you detect, we can do what? We can search for campaigns. And we did the whole thing again. And we were pretty sure that we would find evidence, strong evidence of that, especially related to some candidates. Even the public ministry expected that. But what we observed as something that really scared everyone was that this was massive. This is a small sample of the communities, huge communities, massively connected, doing only propaganda as early as January and it's allowed after August. And for all the candidates, not only right wing, but left wing, everyone. It's like no one's land. People discovered that and are exploiting that like crazy. And then the public ministry now had a problem because he had to work with that. We had like this tool, very nice tool where we show the communities with higher chance of being spreading propaganda. But a few months after we give this to the public ministry, what happened? Elon Musk happened. And this was for Twitter. So I don't know what happened with them because now we cannot collect tweets any longer. Well, finally, one thing that we did, and this, as I said, is coming out next week. It's going to be presented at ICWCM. We looked into Telegram. Again, we know that Telegram was used. Many people moved from WhatsApp to Telegram. Actually, our former president, invited people to follow him to Telegram publicly. So there are many people, and we knew that Telegram was used in 2022 election. And we wanted to analyze, to understand to which extent it was exploited to disseminate content related to the riots. So if you don't know, what happened is that our former president, he lost elections. And in January, 1 week after the new president assumed his power, there was this massive amount of people, riots, who invaded Brezil, our capital, and they broke many things. So this is like a minor version, a PG-13 version of what they did with our capital. They broke everything. And it was huge. I chose this one because of the size of it. So again, we did similar things. We analyzed around the first round of the election, the second round, and the riots, 1 week before, 1 week after, what happened. And what we see is that as we apply different backbones, we see increased community organization. We want that. Very tightly connected communities, especially as we look closer to the riots. Very tightly connected communities. They are sharing many, many times the same content. And what we see is a small fraction of users, 10%, 6%, being responsible for 61%, 41% of the messages being shared in these groups. So it's a massive amount of content they are generating. And they are getting engagement because Telegram gives us number of views, which is good. So it's huge amount of engagement, whatever they are sharing. And they are introducing content very often. The first time the message was shared in the environment that we analyzed, in the groups, most of the time by these people. And if we look at the content they are sharing, we did a topic analysis, then we see clear the narrative behind the riots that we know from anecdotal evidence. But here we see like the top one topic, military intervention. That's what they were advocating for, right? Like 420 million views of this message. And organization of the rallies in Brazil, exactly the riots. Well, this is just a tiny few examples of the analysis that we did. As I said, we are presenting this in ICWCM next week. To finish up, and this I'm gonna very skim, I will not have time to show, but this is a short, big detour from the talk, but it's something that I'm feel obliged to talk about, which is collective behavior in science. And by that, I mean collaboration to produce scientific information, meaning co-authorships. First disclaimer, co-authorships, collaboration is excellent. I'm all for it, that's why I'm here. I'm searching for it. But it may become a concern, an issue, a question mark in your mind when you see some peculiar patterns. And people are calling those patterns hyperprolific authors. I don't know if you know about this work in Nature 2018, where they analyzed scientists in many different domains, and they found that thousands of scientists publish one paper every 5 days. And then you feel so sad, right? I feel very depressed when you look at that. But then this is like cross different domains. Some colleagues of mine in my university, what they did is they focus on computer science. Why? Because we understand computer science. We understand what we know, we from computer science, what we know what's reasonable in terms of co-authorships, in terms of publication, because in different areas, it's different. Health, social science is something, health science is different. So let's focus on computer science. And they analyzed authors in computer science for the past 10 years. And they built like they call it a hyperprolific score. And it's not in terms of absolute numbers. It's rather the increase, the acceleration, and the speed at which the number of papers per year increased. And the number of co-authors increased because it's related. And here they focus only, it's important, journal papers. It's not all publications, and it's important for computer science because in computer science, we do a lot of conference publications. So here is the focus only on journal publications. And then you find people that started 10 years ago from a few papers or no papers per year, journal papers, and reach up to 45 papers in a year. 120 journal papers in 1 year, 75 papers in 1 year. Why do I care about that? First, because I feel very frustrated when I see that, right? But second, because I'm a part of a committee in Brazil, CNPq, that's equivalent to an SF in the States. I don't know what you have here, but it's like the main funding agents. And we analyze project proposals, grant proposals. And now I'm seeing this firsthand, because when a researcher submits the project, I see her resume or whatever, and then I see some weird patterns that I cannot say, anything that I say here, I cannot claim that it's wrongdoing at all. And even there, we see that it's not possible, because we're thinking of Brazil, and we know Brazil, and we know this place, and it's not possible, and we cannot claim wrongdoing or anything. So I was really interested in this, looking at that, and we applied a similar strategy. We are looking at this, we call like the very persistent and repetitive co-authorship, but again, out of the pattern. To which extent these hyperprolific authors rely on those very, 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 very strong co-authorships. And what we found is that if you take the backbone, we do see a strong correlation between having very strong co-authorships and hyperprolific. Again, this link is not that I publish a lot of Najib. It's that the frequency at which I publish with Najib is so out of my pattern that it's weird. That it's weird, peculiar, whatever you want to call it. Okay? And this is there is a transitive relationship. If I use a lot, if I have many of these links, most of my neighbors also have most of these links. And it's increasing over time. People are increasingly relying on those edges over time. Well, we just did this paper, it came out earlier this week, it's scientometrics. The idea was this, is to study hyperprolific authors in computer science from a network perspective. Okay, but I mean, my interest is trying to understand how a person can get to this or this, especially in Brazil. I mean, these are not Brazilians, but in Brazil, you see some weird stuff, not in absolute terms, but as I imagine that you see in many different places, because since I started working on that, I saw many papers in different places talking about this. Okay, well, let me finish up because I already took lots of your time. So I just tried to give you an overview of what we're trying to do in terms of modeling user behavior. As I said, I'm very interested in understanding behavior, but I'm very much focused on the system. So how is Telegram in terms of an environment? What can we do? Can we do anything? Not sure. There's lots of challenge when you're trying to understand and model human behavior. There's heterogeneity, complexity. There's this idea of noisy signals that you have to get rid of. Otherwise, you're going to get lost in the analysis. I didn't talk much about this, but I'm very interested in trying to operationalize cognitive concepts, like the idea of curiosity. How do you model curiosity? And we are working with this idea of backbone. We're applying this in different contexts. There are different strategies. There's a huge room for improvements in terms of the model that we apply, in terms of the dynamicity of the backbone, which the work done so far is very initial. But that's it. Thank you. Sorry for taking much of your time.
Questions?
So, there is a big literature on identity detection in various types of spaces and graphs and Euclidean spaces. And so how does this connect to this literature? Well, I understand that you apply that, you first do a filtering to get this backbone.
Yeah.
And then you try to identify the communities on the backbone and you refer to various algorithms. But more globally, I mean, what are the connections between the communities before applying backbone and the communities after applying backbone?
I didn't show. Yeah, it's exactly that. Like, especially we used a very basic is not a good name, but it's a widely used community detection capabilities for one.
To start doing the backbone and then
both. We started with the community of the network. I didn't show, but we did. No, I don't have it, but we did. And then what we had was very weakly structured communities. So you have like a metric of that, which is modularity, and you looked at the communities. And the problem is that you have many edges, cross community edges. So the structure is weak. So that's why, and we tried to make sense of it, and we couldn't. It was very hard to analyze. That's when we took a step back and said, but these edges here has nothing to do with what we're trying to do. How do I identify those edges that are relevant? Then there is this huge literature on network specification. And then I realized recently, actually, that many of the methods there, they look at the problem from a redundancy perspective. So the network is dense, the network's redundant. Let's get rid of the redundancy. Fine. But my problem is different because it's not only redundancy, it's irrelevance for the problem. So I allow for removing nodes, which some of the backbone extraction methods do not allow. They assume that all the nodes will remain there. Then there are families of methods, different methods. And what we saw, there are like a network backbone applied to co-authorship network, just as we did, not for the same purpose. But what we try to do with one of the first works was try to compare these methods under common perspective of analysis. And what are the assumptions? When will I use this type? When should I use that? I have this phenomenon. Should I use this filter or not? What do you mean? What's the compromise that I'm making to analyze fake news and campaigns by using disparity filter? So I know it's the reference model. So I'm assuming the uniform distribution, but this might not be true, right? It's a weak link there that could change. So in a sense, to my knowledge, there's lots of work on community detection. There is lots of work on sparsification, including some backbone that are like focused on a sample of the nodes. But to my knowledge, we are the first to try to first look at cross methods in terms of a common knowledge of try to compare this. How do you compare different methods and apply to this?
Yes, but so is there a result which says that we can first, how do you call it, I mean, make this threshold link, for instance, namely define the backbone, and that the communities that you discover once you've made this backbone have something to do with the true communities that you could have applied directly on the initial point.
No, because I don't have ground truth. I don't have ground truth. For my phenomena, I do not have ground truth. So I cannot tell. All that I can tell is characterize the communities, see what they are talking about, see evidence from them. And then what I found is that the communities in the backbone, they more often share content with properties that are related to what I want. They have a stronger community organization by modularity. And then I can characterize that. But I cannot. In many moments I can claim that I'm getting the right thing. That's why I should have emphasized that it's with high probability, with a high chance, not even probability, because it's a non-supervised.
So what you say is that there are some limitations, therefore you build the backbone and then find the communities on the backbone, and you do not claim that it always builds the true communities that you would have built if you would have applied any classical community detection things on the initial data.
No, that I can tell, because we build we extract the community from the original data and we analyze it, and it's worse. No, what is it? Here. This is the complete network. That's the modularity of the complete network. I cannot tell whether maybe some of the communities are true communities which are lost here. That I cannot tell. But from a topological perspective, whatever I keep is better structured. You see what I mean? And we also have this a strategy that it's interactive. It doesn't answer the question. The answer is still going to be no. Okay, but we have this idea of correlating the weight of the edge with properties that are related to the phenomenon. You build a regression of it, and then what we show is that the regression is better with the backbone than with the computer. But again, I cannot make any strong comments because I don't have. Yeah.
Okay, one question about is it possible to detect some leaders in the groups?
Yeah. In the communities?
In the communities.
Yeah, because you could look both from a topological perspective and from a sharing perspective.
So it's possible to detect that.
Yeah.
So we could do centrality metrics inside the.
Yeah, we did global, but we could do within the community.
And perhaps the second question is, I know, yeah, you consider only WhatsApp, but in the first experiment, but is it possible to have different perspective, different data sets from different social media, and then try to cross the data set to find if the communities behave the same, or perhaps it's difficult to say that they are the same communities, of course, but that the behavior is the same on that social media or compared to that social media, and perhaps finding or giving some raise to social media that this one is doing a better job than that one, or something like that. In terms of
we didn't, but if this is, we could at a qualitative level, right? That we could, because we cannot find Najib in WhatsApp. And even like matching the communities is hard, right? Because the communities evolve, and how do you match? This is a challenge. But you could do from a qualitative perspective, like the backbone in the WhatsApp is this with this percentage of messages, and in Telegram is this. Good. What we found for Telegram in 2022 was not equal, but qualitatively similar what we observed for WhatsApp, except that maybe because for Telegram, our analysis was really focused on like October, December, January election. But there we could find the same people in the different communities. But I also think that Telegram was this was like a stronger social movement in terms of engagement of people than 2018. So 2018, my perspective is people changed. They changed numbers, they changed groups, and I know that made the difference. I know that WhatsApp, well, there's a claim that it made a difference, but I think the role that Telegram played in 2022 was much stronger in terms of discussion and people organizing themselves towards the rights.
It could be possible to characterize the users like like perspective of age or something like that, because I think that people intelligent would be younger than people in WhatsApp.
All we have is an ID.
Okay.
Not even, we don't have anything. We have just an ID. So unlike other social media.
So if there are other questions, you can stay here if you are still available some minutes, but I would like to free people. So thank you for the very inspiring. And whoever wants